Hey everyone, in this video we're going to learn how to graph systems of inequalities from word problems. Our directions: write and graph a system of inequalities to model each of the following situations. So we've already had practice writing a system of inequalities from word problems. Now we're going to take that system of inequalities and represent it graphically so that we can come up with potential solutions to the word problem. Our first example: Ashley sells bracelets and necklaces at the local flea market. She charges $12 for a bracelet and $30 for a necklace. In one day, she sells at least 5 bracelets and has earned at most $240. With every word problem, we have to start by defining our variables. So we'll let X be the number of bracelets that she sells in one day, and Y is going to be the number of necklaces that she sells in one day. So with our variables defined, we can now create inequalities. So it says in one day she sells at least 5 bracelets. So that means X is going to be greater than or equal to 5. And she's earned at most $240. Well, let's create an expression to represent how much she's going to make. Each bracelet, she's going to make $12. So that's going to be 12X. Each necklace is $30, so 30Y. And that value, how much she earns, is at most $240, so less than or equal to 240. So we have our system of inequalities. Now we have to figure out if we need to scale our axes before we begin graphing. In order to do that, let's figure out what the x and the y-intercept of our second inequality is. Our first inequality has an x-intercept at 5, so 5, 0, and no y-intercept. It's going to be a vertical line with a solution set. So we'll start with our x-intercept. So that's the point whose y-coordinate is 0. So we'd have 12x plus 30 times 0 equals 240. Notice we are changing it to an equation to solve for the x and the y-intercept, finding the x and y-intercepts of the line that's part of this inequality. So we'd have 12x equals 240. Divide both sides by 12. X equals 20. So our x-intercept is 20, 0. The y-intercept is the point whose x-coordinate is 0. So substituting 0 in for x, we're going to get 30y equals 240. We can divide by 30 on both sides of our equation. Y is going to be equal to 8. So 0, 8. Now, in order to fit the x-intercept of 20, 0, where we have 10 boxes here, we're going to have to scale the axes. So we'll go by 2s. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We could label each mark. I like to skip every other just so it's not too cluttered. And then we'll go up the y-axis. We don't need to scale, so we'll just go by 1s. 5, 6, 7, 8, 9, and 10. Since we just labeled the axes, let's label what each represents. So the y-axis is the number of necklaces, and the x-axis is the number of bracelets. So we'll start by graphing our second inequality that we found the intercepts of. So 20, 0, 0, 8. We're going to connect those 2 points with a solid line because it's less than or equal to. We have equality. And then we have to figure out where to shade our solution set. So if we think about the test point of 0, 0, we'd have 0 plus 0, which is 0. Is that less than or equal to 240? And it is. So we're going to shade below the line. And then x is greater than or equal to 5. So x equals 5 is going to be a vertical line from the point 5, 0 going up. And we're going to shade x is greater than or equal to 5. So we're going to shade all the points whose x-coordinate is greater than or equal to 5. Now, because we have two inequalities on our graph, we need to label each of them. So we'll label this as x is greater than or equal to 5. And then we'll label here, we have 12x plus 30y is less than or equal to 240. So our solution set is where the shaded regions overlap. So here is the solution set. So what does that mean? Well, any point in this region would be a potential combination of bracelets and necklaces that Ashley sold. So for instance, 12, 2 is a point in this solution set. So she could have sold 12 bracelets and 2 necklaces. Now, we do have to understand there are some points in this solution set that wouldn't make sense in the context of this problem. For instance, 8.5 and 1.5 is a point in the solution set. But that point wouldn't make sense in the context of this problem because we're not going to sell half a bracelet or half a necklace. Okay, so we're using our math tools, which is graphing our system of inequalities, so that we can come up with reasonable answers to the word problem if they asked. Okay, in this case, they did not ask us to come up with a combination, but they often do. Our next example, the local ski shop is ordering rental skis and snowboards for the upcoming season. They need to buy at least 100 skis and snowboards combined, with the number of skis being at least 3 times the number of snowboards. Defining our variables, we'll let x be the number of skis and y be the number of snowboards. Now that we have our variables defined, we can create our system of inequalities. They need to buy at least 100 skis and snowboards. So that means x plus y has to be greater than or equal to 100. The number of skis needs to be at least 3 times the number of snowboards. So the number of skis is x. That needs to be greater than or equal to 3 times y, which is the number of snowboards. Now we need to figure out if we have to scale our axes. So we'll find the x and y intercepts of our first inequality. So the x-intercept when y is 0. So this one is a little bit easier. We have just x plus 0 equals 100. So x is 100. And the y-intercept, the point whose x-coordinate is 0, so we have 0 plus y equals 100, which is y equals 100. And our other inequality, let's put this in a y equals form, more familiar to us. So y would be less than or equal to 1/3 x. So to graph this line, we notice that the slope is 1/3 and the y-intercept is 0, 0. Okay, so to fit that point on, we don't really have to worry about scaling, but to fit 0, 100 and 100, 0, we do. So we have 10 boxes on each axis, so we'll scale by 10s. So skipping every other, we have 20, 30, 40, 50, 60, 70, 80, 90, 100. And the same thing going up the y-axis. We'll label what each axis represents. So the x is the number of skis. Y is the number of snowboards. And now we can graph our two inequalities. So we'll start with x plus y is greater than or equal to 100. So we have a point at 0, 100 and 100, 0. We're going to connect those 2 points with a line, a solid line because we have equality here. And we are going to shade, so x plus y has to be greater than or equal to 100. So if we test the origin, 0, 0, is 0 plus 0 greater than or equal to 100? No, that's a false statement. So then origin is not in our solution set, so we shade above the line. And that's going to be x plus y is greater than or equal to 100. Now we have to graph x is greater than or equal to 3y. Or, as we manipulate it, y is less than or equal to 1/3 x. Now, graphing a slope of 1/3 is going to be tough because, well, one box is 10, not 1. So if we can rewrite this slope so that we have factors of 10 in the numerator and denominator, it'll be much easier for us to do. So we can multiply the numerator by 10 and the denominator by 10, and we would get a slope of 10/30. That's going to be much easier for us to graph. So we have a y-intercept at 0, 0. Then a slope of 10/30, well, up one box is 10, and to the right 3 boxes is 30. Up one box over 3, up 1 over 3, and we're going to connect these points with a solid line. We have less than or equal to. So there's our line. And now we need to shade our solution set. So x has to be greater than or equal to 3y. So if I pick a point on the x-axis, so let's say I pick 60, 0, is 60 greater than or equal to 3 times 0? Is 60 greater than or equal to 0? The answer to that is yes. So that point that I picked, 60, 0, is in the solution set. So we're going to shade below the line. So this is x is greater than or equal to 3y. So our solution set is this region here. And that's going to extend off our graph, but at least on our graph we have overlapping shading. And if they were asking for a potential combination of skis and snowboards, if we pick a point, like right here, 90, 20, if they buy 90 skis and 20 snowboards, then they'll have met both of their requirements. And there is the graph of the solution set. Next up, the high school drama club is selling tickets to their charity talent show. The auditorium could hold at most 300 people. They are hoping to raise at least $2,000 by selling $5 student tickets and $20 adult tickets. Defining our variables, we'll let x be the number of student tickets. And we'll let y be the number of adult tickets. So now we can create our inequalities. So the auditorium can hold at most 300 people. So that means x plus y has to be less than or equal to 300. They're hoping to raise at least $2,000 by selling $5 student tickets and $20 adult tickets. So if they sell x student tickets, then they're going to make $5x. Y adult tickets, they're going to make $20y. And they want that quantity to be at least, so greater than or equal to 2,000. So we have our system of inequalities. Now we have to figure out our scaling. We'll start with the first inequality, finding the intercepts. So the x-intercept, well, if y is 0, then x is 300. Right? We'd have x plus 0 equals 300. And the y-intercept is going to be 300, 0, 300 rather. 0, 300. And that would look, plugging 0 in for x, plus y equals 300, y equals 300. Now we need to find the x and y-intercept of the second inequality. That's going to take a bit more work. So we'd have 5x plus 20 times 0 equals 2,000. So 5x equals 2,000. If we divide both sides by 5, we're going to get 400. So 400, 0. I'll rewrite that just so it doesn't look so cramped. So we'd have 400, 0. And the y-intercept, running out of room since we have to do two inequalities. So we have 5 times 0 plus 20y equals 2,000. So that would be 0. If we divide both sides by 20, y is going to be equal to 100. So we need to figure out a scaling for our graph that fits all 4 of these points. So let's make each box 50. So 50, then 100, 150, 200, then 300, 400, and 500. And we'll do the same thing up the y-axis. We have 100, 200, 300, 400, and 500. So the y-axis is the number of adult tickets. The x-axis is the number of student tickets. And now we have everything labeled, we have everything scaled, now we can graph. So we'll start with the first inequality, so 300, 0, and 0, 300 are the x and y intercepts. Connect the 2 points with a line. And we need to shade the solution set. So x plus y has to be less than or equal to 300. So the origin, 0, 0, would work in that inequality. 0 is less than or equal to 300. So we'll shade below the line. And then we'll graph the next inequality, so 400, 0, and 0, 100, connecting those points with a line and shading the solution set. So 0, 0, if I test the origin, is 0 plus 0 greater than or equal to 2000? It is not, so origin is not in the solution set, so we'll shade above the line. And technically we need to extend this all the way up. So now I can label, I was waiting to finish it, so this is 5x plus 20y is greater than or equal to 2000. And in blue we have x plus y is less than or equal to 300. Our solution set is where they overlap. So there is the graph of this system of inequalities. And then they do ask us a follow-up question. If they sell 200 student tickets and 40 adult tickets, will they reach their goal? So 200 adult and 40 adult tickets. So that's like right here, and it's tough to tell off of the graph. And they probably did this on purpose so that we had to check it in another way. So that way is going to be plugging in the point 240 into our system of inequalities. So is 200 plus 40 less than or equal to 300? Is 240 less than or equal to 300? It is. So they didn't sell too many tickets. Now are they going to sell enough to make their goal? So 5 times 200 plus 20 times 40, is that greater than or equal to 2,000? So is 1,000 plus 800 greater than or equal to 2,000? So is 1,800 greater than or equal to 2,000? It is not. So will they reach their goal? No. And if we go back and look at the graph, 240 is definitely going to be a little bit below where that line is. Okay, so we could have figured out off the graph, but because it was close, we can check our work algebraically. One more example. Delilah has 2 summer jobs, working at the movie theater and babysitting. She earns $8 an hour at the movie theater and $18 an hour babysitting. She wants to earn at least $360 a week, but work no more than 30 hours. Defining our variables, we'll let x be the number of hours at the movie theater. And we'll let y be the number of hours babysitting. So we've defined our variables. Now we need to set up our system of inequalities. So she wants to earn at least $360 a week. She's going to make $8 an hour at the movie theater and $18 an hour babysitting. So that means 8x plus 18y needs to be greater than or equal to 360. And she doesn't want to work more than 30 hours. So x plus y has to be less than or equal to 30. Now that we have our system of inequalities, we need to figure out our scaling. We'll do that by finding the intercepts. So for our first equation, the x-intercept, when y is 0, so when y is 0, we are going to have 8x equals 360. So if we do 360 divided by 8, we get 45. Running out of room here, so x equals 45, so 45 comma 0. Our y-intercept, when x is 0, we're going to have 18y equals 360. So doing 360 divided by 18, y is going to be 20. Okay, so we have our x and our y-intercept there. And from our second inequality, the x-intercept, well, if y is 0, x is going to be 30. And our y-intercept, when x is 0, y is 30. So I didn't show as much work to find these intercepts. Hopefully you can use the previous examples to follow my steps, and you would agree that all 4 of these points are correct. So we need a scale that's going to fit 30, 20, and 45 if possible. So if we scale by 5s on the x-axis, 10, and then 20, 30, 40, 50, that would work nicely. So 5 and then 10, 20, 30, 40, and 50. And we can repeat the same scaling. That will fit both 20 and 30 nicely on the y-axis. 10, 20, 30, 40, and 50. So the y-axis we'll just label as babysit, and the x-axis we'll label as movie theater. So now we can graph our 2 inequalities. So the first one, 45, 0 is the x-intercept, 0, 20 is the y-intercept. Connecting the 2 points and shading our solution set. So 8x plus 18y needs to be greater than or equal to 360. So if we test the origin, 0 plus 0 is not greater than or equal to 360. So we shade above the line. Let's draw an arrow. So that's going to be 8x plus 18y is greater than or equal to 360. Then plotting our other inequalities, so 0, 30 and 30, 0 are the 2 intercepts. Connecting those 2 points. And shading in our solution set. So x plus y needs to be less than or equal to 30. So 0, 0, the origin. Is 0 less than or equal to 30? It is. So we're going to shade below the line. And that's going to be x plus y is less than or equal to 30. So our solution set is where they both overlap. So that's going to be in this region right here. So there is our solution set. So any combination of ours is going to fall there. Any combination that meets her requirements of making enough money and not working more than 30 hours. So state one possible solution and explain what it represents in the context of this problem. So we can pick a solution. So I'll pick the purple pen. So right here, that point's nice and in the middle. So that's the point 5, 20 as our solution in the solution set. So what does it mean? So that means 5 hours working at the movie theater and 20 hours babysitting. Perfect. So as you notice, a lot goes into a system of inequalities word problem. We have to define our variables, we have to create our system of inequalities, we have to figure out the scaling of our axes, and the best way to do that is find your intercepts. Then we have to graph our system of inequalities, making sure we label both solution sets. And then from there, if they ask a follow-up question, such as state a possible solution, or does this combination work? Does it make the word problem correct or incorrect? A lot goes in. Okay, so practice a few of these so that you get the nuances and pay attention to all the details.